in Prolog. So I will also demonstrate it. So the left hand side will be called as a rule. So even though they call it as implications in Prolog, at some time they are not real implications as in the predicate logic. They are all mere rules. So the real name of it is the rules. That you have to understand. Why we are discussing about Prolog is because we are not, our topic is not language specific. It is a familiarly used environment in artificial intelligence. So if that is there, it has some problems. To identify the problems in such implementations, we are taking up those languages and discussing about it. So then, moreover, I would like to present some of the informations about this prologue a little bit later. So now we will go into the areas which are related, which are looking alike. They are lookalikes in the in the field of intelligence about that is to the proposal what we are giving. So these lookalikes, they are lookalikes only. They are not identical. They have some similarities and we have differences also. So we have to mention them. The lookalikes have to be discussed because we are not duplicating the already done work. So that is most important. That is why we are going for the lookalikes to be discussed. So the knowledge graph is the first and foremost lookalike to the solution or to the model what we are prescribing. So here a knowledge base is a composed of a subject, predicate, and an object. So when we talk about a particular statement in a life, a subject, predicate, object will be there. So this relationship will be represented as a knowledge graph. So which is there, this is already there in artificial intelligence. So in area of artificial intelligence. So now if these graphs are considered to be a Putin president of Russia, so it's a sample which we have taken from the internet only. So we can give our own samples also. So when we give for an example, if this represents as a just a graph represents just the relationship between two items, it is mere data representation. So here nothing is functional. A president of, you do not have a function there. So there is a link between Russia and that link is labeled as president of. So then if there is a Ramnath Govind is the president of India. So in that case, if you define them, there will not be any interlink between these things. So the facts are represented as graphs, and what happens here is whenever the inference engine has to process through these facts one after another. So, and working through these disconnected graphs is going to be more complicated. So, these knowledge graphs are not used as generic knowledge base building areas. It is used in the area of domain specific knowledge representation area only. So, there the data will be represented in the form, the only domain specific will be there, disconnectivity will be minimum. So, then they will be parsing or passing through these data or processing through this data and then achieving the link between them or inferring from the connection available will be happening using an inference engine written as a procedure. Inference engine written as a procedure. So now this is about, but our model is going to be different from it. How different, we will come to that later. So this is what which we already have in the area of artificial intelligence. So now we will get into the other lookalike, which is a knowledge graph. A knowledge graph is the next lookalike what we have. So the knowledge graph is used in the inference engines where I would like to, so it's a triple, what we call it as, so it is also called as a Bayesian network or, sorry, the next one is a Bayesian network. I am once again, I have marked this knowledge graph. The next lookalike is Bayesian. So this was given as in the area of provides enterprise knowledge graph. That is why they call it as enterprise knowledge graph. It is domain specific. Normally it is domain specific. So to avoid that is difficulties in searching through disconnected graphs will be difficult. So they say that it should be domain specific. To explain that, we have an example. They decide or they define a knowledge graph for an enterprise so that they make it into a specific area of definition. So in that case, the disconnected graph problem will not be coming. So that is how it is being used nowadays. And then the next lookalike is going to be a Bayesian network or belief network. It is also called as a belief network. Even they use the similar term, what we use, they are using it there. But how we are different, we are going to say that later. So now the Bayesian network can be build-up model. So it has three things. It is having a directed acyclic graph. These are directed acyclic graphs. Who define them? It is defined by the agents or an expert. In other words, experts can define an agent. So, and a graph will have a table of conditional probabilities. It will have the conditional properties. So now, what do you mean by this conditional property? So, for in a knowledge-based system, for every combination of that is the data which is available, there will be a probability. So now if we have burglary and earthquake, so let us take up the example which is available in hand, a burglary and earthquake. So in both the cases, an alarm has to be risen, and there may be a David calls and Sophia calls. So these are two activities which are, this may come to us in a particular place and environment. These activities may be an available thing. So when what can happen is, so there may be, that is due to a burglar or a thief has come. So then we identify the burglary and then alarm can go. At the same time, earthquake can come. So now these are all related items. So whether true in the both the, in if even at least one is true, then the alarm has to go. If both happen, then also there should be alarm. But when for a particular person calls, the alarm should not be risen. So they are non-independent activities. So we have to understand, whenever some situation is taken into, or scenario is taken into account, there will be various activities. So there will be different combinations available. But whenever we write it as a single truth table, so there will be 5 possible columns. 1 to burglary, to earthquake, this may be true, this may be true, this may be true, this may be false, this may be false, or any combination can be. So in that case, the possibilities and the total number of possibilities are going to be 2 to the power of 5. So that is 2 to the power of 5 is going to be the maximum possibilities of the combinations, that is equal to 32. That is equal to 32 will be the probabilities we will be having. So if you want to calculate the probabilities, we have to have 32 probabilities, and they will be called as, so that those probabilities will be according to the experience or of the experience of the expert. So he has to predict for or associate priori possibilities. So we call them as, so what this knowledge graph does is, belief net does is, it translates priori probabilities into posterior probabilities. So now after an experience, the posterior probabilities, it is posterior probabilities, it is calculating. So in that case, the priori possibility is set by the experiencing person or an experienced person, and there will be observations following it. So his whatever probability is assigned has to be modified according to the experience. So the observations are added, the observations are once after another follow, and then once they come, the posterior probability has to be calculated. If 32 so if for even for just 5 columns available, even if they are true or false, there will be 32 combinations. So if the number of columns increase, or if it is a random number of columns, so then the number of probability which has to be assigned and which has to be calculated will be too much. So in that case, what they do is, they calculate only the, that is the, he defines, a particular expert defines the dependency graph. He defines a dependency graph between the variables, and then the, according to the dependency variable, how he does it. So the each and every particular column will have a respective probability table. So in that case, what happens here is, if only the alarm is dependent on these two, so the burglary doesn't depend on anything, earthquake doesn't depend on anything according to the environment, but the alarm depends on these two. So now this can be true or false. Only two probabilities can be, has to be set. here true or false, only true probabilities has to be said. And totally when it comes to alarm, there should be 4 because it is dependent on both these two, and these two are independent activities, so the only 2 will be there. So totally we will be having 12 probability calculation is enough. So they minimize the probability calculation according to their conditional probabilities, we call them, and they calculate this. So now why they call it as a belief net is because this is what the belief of an agent is. So this belief of an agent is tested by the observations, the later on observations, and the whole belief is evaluated. So similarly, another person can have another set of kind of belief about an environment, and he can also build a net, and he will be trying it, and he will be calculating the probabilities according to the same set of observations, and the functioning the final probability can be assigned by evaluating or comparing between these two evaluations. So this is how the belief net works. So why they call it as a belief net is because it is the belief of the particular person or a particular agent. So similarly, so we also do it, but in our methodology, we are going to, so the same belief net can be implemented very easily. Instead of writing at a procedure and then representing as an indirected graph, so this implementation is going to be easier with respect to our model, what we are proposing now. So now what we propose here is the reasoning behind the design and requirement of belief module is, so before going into the design how we are going to do it, we have to understand about the predicate logic. Once again, we go back to the predicate logic. I have taken an example. So these are all the propositions what are already given. So the propositions means, so here's a particular situation. We observe that for every x food of x is liked by John X. So John likes all the foods. John likes any food. So if it is a food, he likes it. That is what it is meant for. So now if these kind of statements are given in predicate logic, immediately till date what is happening is this implication, this has to be converted into first order logic, FOL clauses. First order logic clauses, they call it as, in other words, conjunctive normal form, CNF. They have to be converted into conjunctive normal form. This has to be converted. So for that what they do is they eliminate this implication. So what we have told, our objective is to mimic the brain. So artificial intelligence is to mimic the brain. So here they intelligently do this. Artificial intelligence does not have the plausibility to the biological brain functioning, but it does the function what a brain does. So but I would like to explain it with a small example. If I say, if it's raining, if raining, I will just write it as if raining, then it will be cold. So let us assume if it is raining, it will be cool. So now let us consider if this is the statement here, then it is converted into, how it is converted into is, if it is not raining or not cool, or cool. It is not raining. It is not raining, not rain or cool. So now this is converted into it. So now here this looks like an implication. Raining implies this symbol you can use, cool. Raining implies cool. So this looks understandable by a human brain. But when you go into the first order logic, how it is converted into is not rain or cool. What does it mean? Do our brain very easily understand it?